Welcome back. All right, so we're going to complete some reflections in the coordinate plane. All right, so here we're going to start off with the coordinate plane with no numbers. And I'm going to have you write this in your notes, even though this particular problem isn't in your notes, but I'm going to put over on the board here will be useful. And so here we have no number values we can use. However, we can still figure out where our image is supposed to go because we can use this property. The distance from a point on the image to the line of reflection is equal to the distance from the corresponding, missing an S there, point corresponding point of the image. Make sure my sentence is here. So the distance from a point on the image to the line of reflection is equal to the distance from the corresponding point of the pre-image to the line of reflection. Just checking to make sure I was writing what I intended. All right, so in other words, B here is 2 horizontally from the line of reflection. B prime is also 2 horizontally, but in the other direction. A is 1, 2, 3, 4 away from the line of reflection. A prime is 1, 2, 3, 4 in the other direction. C is 1, 2, 3, 4 away from the line of reflection. C prime is 4 away in the opposite direction. And that's all there was to finding our image for this line of reflection. And there we are. All right? So we can use properties to find where our figure should go. Properties of reflections. And by the way, we're going to use the same idea when we are reflecting in the coordinate plane over a line, not the x or y axis. So you'll see that in a moment, or in a few moments. Here's our next one. I don't have this one in your notes. I have another one. I kind of wish I had done this one. This one's a little bit more challenging than the one I gave you, but that's okay. All right, so here we have a diagonal line. Right? So now we can use properties of reflections. All right, so let's think about one property of reflections is that a line segment connecting that's the word corresponding. I don't know, R looks really kind of funny there. Corresponding points on the pre-image and image is perpendicular to the line of reflection. So without even knowing where exactly my points are going to be, we can find out at least what line they should be on. So for instance, let's take a look at the slope here, and so we can find our perpendicular line. All right, so the slope of our line of reflection has a slope of 1. Right? You can see that the line goes up 1 to the right 1, up 1 to the right 1. the slope of the perpendicular line, we know that perpendicular lines have slopes that are negative reciprocals, right? So if we flip the 1, right, we can think of it like that, we flip it, it's still 1, but then we flip it and make it the opposite because it's a negative reciprocal, right? So we're going to have a slope of -1. Right, so now let's draw a line with a slope of -1 from each of our points on the pre-image. Right, so here I'm going to start at C, and notice here I have a slope of -1. I'm going up 1 to the left, up 1 to the left. Or you can think of it as cutting across, a diagonal across a bunch of squares. That's the way I think of it. I'm kind of just going across squares. Just see all those little things as squares. All right, let's do the same thing for A. Right, so from A, I'm going to draw a line with a slope of -1. And from B, I'm going to draw a line with a slope of -1. All right, so let's write down what we did so far. All right, so finding image for reflection. And by the way, you can write this in your notes because we have one that's almost like this that's coming up next. So I won't have to write it down twice. Right, so find a little spot to write it. Or use a sticky note. So finding image for reflection over a diagonal line. And this is really helpful when you have no coordinates here. Right, so if you find the slope, or if you have a really tricky diagonal line, find the slope of the line of reflection. I'm going to abbreviate line of reflection. Line of reflect. Then you're going to find the slope of the line, not the, of the line perpendicular to the line of reflection. And you're going to draw this line. So draw a line with perpendicular slope from each point on the pre-image. Right, so we know that our image is going to be on this line. Or on these lines, I should say. There's 3 of them. Right? So now how do we find where? Just count diagonally to find the location. So why would you want to draw these segments? It'll keep you counting in the right direction. Right? Perhaps you thought B and C were on a line, on the line with a slope of -1, but they're not. Notice that segment that connects B and C does not have the same slope as these lines that are perpendicular to our line of reflection. Right? So we have to be kind of careful when we're counting. This just makes it easier to count. All right? So now let's find our image. So here I'm 1 away, right, on my line. Keep counting. 1 more, and that's C prime. For B, I'm 1, 2, 3 and a half. Right? My line of reflection is cutting, this is halfway between these 2 points. So 1, 2, 3 and a half. Let's just count 1/2 and 1, 2, 3. Here's B prime. And let's do the same thing for A. 1, 2 and a half, 1, 2. And here's A prime. And now we can connect. And we have, oops. I went to go to the, oops. I'm going to the letters and not the points. Gotta make sure I look in the right location. Well, I will move that back once I get rid of this. The points just, the letters just led me astray. There we go. And now I'll put it back. Did I put that in the right location? Yeah. For a second, I thought this was a point, and it's just this prime mark. All right, there we go. All right, so there we've got our image in the right location as we reflected over a diagonal line of reflection. And we can feel really good that we have it in the right location because all of our points are on the segments that are perpendicular to our line of reflection. All right, so pause the tape if you need to write all this good stuff down. All right, this will help you find it even when we have values. Now I am going to teach you some rules that'll help you, and you won't necessarily need to do this. But if it's a line that's not one of our rules, these will be some techniques that you can use to still find your image across a diagonal line of reflection. Right? And also good if it's on dot paper and it has no points at all. This is the one in your notes. The reason I said this one's a lot easier, it's a square. I should have made it a triangle and got rid of the point R there. All right, so this one's a lot easier to draw our lines, our segments connecting our image and our pre-image and image. Let's find the slope of our line of reflection again. So our slope for the line of reflection this time is not 1. This time it's -1, right? We're going down 1 to the right, down 1 to the right. So it's a slope of -1. Right, so that means that the segments connecting the corresponding points, and you know I'm talking about between the image and the pre-image. Has a slope of 1, right? Because they're perpendicular. All right, so now let's do the same thing. We're going to draw our lines from our points. So I'm going to draw a line with a slope of 1, and I'm just going to keep going because I know my image is going to be on this line. Same thing from here. And that's really all I have to do because S and R are on those same lines. All right, so now all we have to do is count diagonally. Right, so we're 1 away. I'll put a 1 there. We're going to count 1 this way. Right, and that would be P prime. Right, so here Q is 1 away from our line of reflection. Q prime is also going to be 1 diagonally. Excuse me. And S is 1, 2, 3 away. Wait, coughing. I'm going to try and finish this image. 1, 2, 3. 1, 2, 3. So right here will be S. And that's because we counted, well, I can't really put it there. But here, I can never draw these brackety things very well. There we go. There we have a distance of 3. So here we have to also have a distance of 3. And likewise, we have the same thing for R as well. 1, 2, 3. 1, 2, 3. So maybe we won't write the same thing in for R. Otherwise, it's going to get kind of crowded. We'll switch colors here and connect our corresponding points. So, I mean, not our corresponding points. Connect the points on the image. I should also write the last point down. That was R prime. All right, so we connect P prime to Q prime, Q prime to R prime to S prime, and S prime back to P prime, and there is our image. I'm going to actually write image because with all these squares, the ones sort of created here by our segments connecting our corresponding points, as well as our image and our pre-image, which happen to also be squares. There we go. Right, so now you can see how to count. Right? So if you put this in your notes, and then put this part in your notes as well. All right? Because this will help you when we have a tricky line. Right? What if we had, not a slope of 1, we have a slope of 2. Right? That gets a little trickier. All right? You can use these same steps. Right? That's why they're very handy. And whether there's coordinates or not, you can use that. All right, so let's look at some rules for reflections in the coordinate plane. So now we're going to have numbers. And so with numbers, we can have rules. Not everything will have a rule, but many of these will. All right, and that's because for certain lines, our coordinates represent distances. So from the x-axis and the y-axis, coordinates represent distances. So let's look at reflecting over the x-axis. So now take a look at the pre-image and the image. It's up here. Right, so this is not in your notes, but just take a look. And you should notice that, let's look at A and A prime, something is different. And between B and B prime, something is different. And between C and C prime, something is different. Have you figured out what's different? So when you reflect a point across the x-axis, the x-coordinate remains the same, but the y-coordinate is transformed into its opposite. So the reflection of the point xy across the x-axis is the point x negative y. So keep the x, make the y the opposite. And that makes sense. We're reflecting over a horizontal line, right? We're not moving horizontally at all. We're moving vertically. So of course the vertical, the y, is going to change. That little hint over there, that's if all other methods fail, all right? Because you're going to have to try to eyeball it, and that might be tricky, right? So if there's no other way, it's a super, super tough one. Not the x-axis and the y-axis, right? That can be a way you can do that. You can try and figure out if you have no other techniques, folding over the line of reflection, so that you can kind of see where it should land. Maybe that will help you, right? But that's kind of like your last resort. All right, so let's find some reflections over the x-axis. We're going to reflect I, J, K, and L over the x-axis. I want to point out this notation here. All right, so the R means reflection, and the x-axis is our line of reflection. I will try to write that. We'll write that same terminology. You don't need to write it down now, but we're going to do some reflections a little bit later on in your notes, and we'll write the shorthand next to it, so that way you'll remember. All right, so I'm going to just write I over here. So I is the point, -4, 3. I prime, reflecting over the x-axis. Keep the x, make the y the opposite. So I prime is -4, -3. Okay, I'm going to switch colors. J is the point, there you are, -2, -4. J prime, we keep the x and make the y the opposite. So it's going to be -2, +4. And if I can follow, this is a little dim for when I'm looking at it. I think it's all right when you look at it. But I've got a projector light behind my head, so there's J prime, and that's at -2, +4. Let's get K prime. Well, let's write down K first, and then let's get K prime. All right, so K is at the point -1, 0. All right, so K prime, we keep the x, make the y the opposite. What's the opposite of 0? It's still 0. It's kind of its own negative. Right, so there it is, K prime, didn't move at all. And then finally, L. So L is located at 4, 1. L prime, keep the x, make the y the opposite, is going to be 4, -1. That's L prime. All right, so now we can connect. And be careful if you're connecting, kind of a square is not hard and a triangle is not hard. You can't possibly connect a triangle wrong, right? Because the 3 points, each point is connected to the other two, right? So no matter which way you go. But with this figure, if I connect the points in the wrong order, I'm going to end up with something weird, right? So for instance, I is not connected to K. Like I and K are not connected. If I go I, K, I'm going to have some weird figure. It's not going to be the same. So just make sure with something like this where it's not a regular polygon, make sure you go in order, all right? So don't just connect any old point you see. All right, so and I'm going to do this in purple so that it's not the same color. All right, so if I is connected to L and J, right? So I can go to either L prime or J prime. Actually, maybe I'll just go to both. J prime and L prime, right? Because I is connected to J and L, right? Then it has to be connected to J prime and L prime. And then L and J both connect to K. So now L prime, oops, that was a little bit too steep there. L prime to K prime and J prime to K prime. Oops, I forgot. If I pick up the eraser, it changes the color of my pen because I don't have a purple pen. There we go. All right, so now the black one is the pre-image, the purple is the image. All right, and you can see that this is a reflection. Notice that everything that's above the x-axis for the pre-image is below the x-axis in the image, and vice versa. Right? So if it's below in the pre-image, it's above in the image. Right? So like this little part here, I shouldn't write in purple anymore. I'll just kind of shade it. So this little part here is below, over here it's above, right? This kind of gives you an idea. Let me get rid of that. Let's do another problem. Maybe I have another one for us to do. Or I have some notes. I have some notes first, then I have another one for us to do. Reflecting over the y-axis. When you reflect a point over the y-axis, well, let's take a look at the pictures there. So 4, 4 to -4, 4, 2, 2 to -2, 2, 5, 1 to -5, 1. When you reflect a point across the y-axis, the y-coordinate remains the same, but the x-coordinate is the opposite. So reflection of the point xy across the y-axis is the point -xy. Let's do the same thing over here. We're going to reflect A, B, C, and D over the y-axis. All right, so A is the point -1, 3. A prime is going to be 1, 3. Right? Keep the y this time, make the x the opposite. All right, B is the point 0, 1. Keep the y, make the x the opposite, but the opposite of 0, well, it's going to be in the same location. So if the point's on the line of reflection, it's not going to change. All right, and then C is at 2, -1. C prime is going to be at -2, -1. Right there. Oops. And finally, D is at -3, -2. D prime is at -3, right in the, or +3, excuse me, -2, right in the middle of my 2, -1. Let me move that out of the way. All right, so right here at 3, -2 is D prime, right? So notice that just the x coordinates change. Looks like D and D prime aren't in the right location from one another. That's just because D is so far away from D prime, from the point. But you can see the point there and there. So that is a reflection over the y-axis. Again, notice the notation there. Little r y-axis means reflection over the y-axis. Let's continue. So now let's reflect over some other line. All right, so each point of a reflected image is the same distance from the line of reflection as the corresponding point on the original figure. In other words, the line of reflection lies directly in the middle between the figure and its image. Good information there. All right, so notice that, for instance, A here is 3 away from the line of reflection. A prime has to also be 3 away from the line of reflection. It has to be that same distance. Right? So I'll show you 2 ways. Counting is very helpful. That's method number 1. Unless you have to count a really long distance and then you get confused, or you have to count so far it's not even on the coordinate plane anymore. I'll show you what else you could do. And we'll do that with G. Right? So I'm going to write that up here, and so you can add this in your notes as well. So finding points over vertical and horizontal lines. Number 1, you could count. So just count the distance, then just go in the other direction. Number 2, subtract 2 times the distance, and you're going to, or I should say add, not subtract, add 2 times the distance, and I'll show you what I mean. And make sure, watch your signs. Right? So if the image is to the left or down, your distance is negative. I wish I had a better location for that. No, this is all located. This is all stuck together. That's what I thought. I think I'm going to move this over here. Oops. I'm not going to move that. Matter of fact, we should lock it. If I can manage that. Lock in place. There we go. I'm just going to move this because it's really, really close. Oop, but when I did that, well, now I may as well leave it there. If you notice, when I moved it, I made it worse. 2 times the distance. I don't even know where this goes. I will unlock that. I'm so sorry. Unlock. Let's move this over. Let's move my words over. There we go. And we'll move this. Oh wait, that's we're in the right spot. Sorry. Right, because we're reflecting over x equals 2. All right, so finding points over horizontal lines, you either count the distance or, there we go, add 2 times the distance and watch the signs. And because left or down is negative. There we go. Now you can read that. All right, let's get to it. All right, so here we'll start with F or E. All right, so our line here is x equals 2. Okay, x equals 2. All right, so E is 1 away. Right, and it's that 1. And so it's going to be 1 in the opposite direction. So that one's easy enough to count. So E prime is at 3, 4. I wouldn't bother to subtract for that one. How about F? I don't think we have to subtract for F. F is right on the line of reflection, so F prime is also at 2, negative 3. But maybe G would be helpful. All right, so G here, so this is x equals 2, and x coordinate for G is at 5. All right, so G here is 3 away. All right, so we'll use our method number 2 here, not counting. All right, so and notice that I'm going in from the point to the line of reflection. I'm going in a negative direction, so the image is going to be going in a negative direction. All right, so let's make that negative. All right, so if we take 2 times negative 3, that would give us negative 6. Right? And we're going to add it to the x-coordinate because this is a vertical line. All right, so I'll add that. For the add there, it's to the x if it's a vertical, and y if it's horizontal. All right, and so if we add 5 plus negative 6, that's negative 1. Right, so it's going to be over here, negative 1, 2. The other thing I could do is count. Right? So I'm at 5, 1, 2, 3 gets me to 2, and then 1, 2, 3 more gets me to negative 1. Oh, this coughing. Let's try this one while I get a drink. All right, let's try this one. We're going to reflect over. Oh, we forgot somebody. We forgot H. All right, so H is really easy. We don't need to subtract. 1 away. Now we're 1 away this way. There's H prime. And that's going to be located at 1, 0. All right, so you can't subtract. All right, so here, if I'm 1 away and I'm going, I'd have to count to the left. All right, so that's negative 1 away. All right, so negative 1 times 2 would be negative 2 away. And notice I'm 1, 2 away. We're just counting if you're that close. The subtracting is helpful. What if we were, the point was far away from the line of reflection, and I was going to actually go off the coordinate plane, then it gets harder to count. All right, let's get to this one. Just a few more to go. Let's reflect M, N, P, and Q over the line y equals negative 3. And these points are so close to that line of reflection, we're just counting them. All right, so let's start with M. Well, M is on the line of reflection, so M prime is the same point. N is 2 away from the line of reflection. All right, so I'm going to count 2 more. Right, so line of reflection is at negative 3, so 2 more is going to be negative 5. So right here, at 1, negative 5 would be N prime. P is on the line of reflection, so it is also in the same spot as P. And then Q here is 2 away from the line of reflection, and it's nice and easy because I'm counting along the y-axis. I need to go 2 away in the other direction. So there is Q prime. And that's all there is to this one. All right, so let's connect. So notice whatever was below the line for the pre-image is now above the line. And there we go. All right? So this little part, this part here, this black line here, now is this red line down here. All right? And notice our notation there, that y equals negative 3 means the equation y equals negative 3, a horizontal line through negative 3. All right, let's look at diagonal lines in the coordinate plane. All All right, so reflection is taking the mirror image of a shape where the mirror line is called the line of symmetry. The mirror line does not have to be horizontal and vertical. It also can be diagonal. So remember how we counted diagonal? This time I'm going to count vertical and horizontal. All right, so here I would have to count 1, 2, 3. All right, so I'm going 3 vertically. Notice now I'm going 1, 2, 3 horizontally. So perhaps since vertical is y and horizontal is x, perhaps the vertical and horizontal distances switch. Let's find out. So here we have the line y equals x and y equals negative x. So reflection over y equals x. Point xy reflects to yx. We switch the x and the y. Reflection over the line y equals negative x. We switch the x and the y and negate, right? Because the slope is negative, right? So now we're coming. So here, if I'm reflecting over this line with a negative slope, here the pre-image, I don't know which one is which. Let's just say it's that one. X and y are positive. If I reflect over the line, I've got to end up down here where x and y are negative. So we're going to not only switch, but we're going to negate. We're going to make the values the opposite. All right, so let's sum all these up. And then in the next podcast, which I'm going to do on the same Nearpod, we are just going to do one problem. All right, so reflection over the x-axis. All right, so we're going to sum up all our rules. Reflection over the x-axis, we keep the x, make the y the opposite. Reflections over the y-axis, this time we keep the y and make the x the opposite. Reflections over y equals x, we're just going to switch the horizontal and vertical distances. Reflections over y equals negative x, we're going to switch them and change the sign. You do need to know these, make sure you do. Reflections over any line, each point of a reflected image is the same distance from the line of reflection as the corresponding point on the original figure. The line of reflection lies directly in the middle between the figure and its image. It's the perpendicular bisector of the segment joining any point to its image. And we learned ways that we can find that when we're finding it over something where we don't have a rule. So these four here we have a rule. X-axis, y-axis, y equals x, y equals negative x. Right? The other ones, we have to use one of our strategies. Counting, subtracting, drawing the segments connecting the corresponding points, etc. In the next podcast, which is coming up right now in the same Nearpod, we're just going to do this last one in your notes. All right, so bye for now, and then we'll finish up.